We're not live. I know we're live. Hello, everyone. My name is Matthew. I wanted to go over can-ss's, really DoneJS's server-side rendering implementation. We're going to be giving a talk about DoneJS next week at the San Francisco can-JS meetup, so I thought it'd be a good time to, it's mainly for me, and I wanted to refresh myself on how server-side rendering works so that when we talk about it there, I can answer questions and stuff. Because it's been a little while since we worked on this particular part of Done. So I thought I'd just go through it step by step. And yeah, interject at any point if you have specific questions or anything. It's kind of interesting. Can you all see my screen? Anyone?
Yep.
Yes? Okay. It's kind of interesting. I'm not on purpose necessarily, but I'm kind of going it in the order that we developed it, just because we kind of started off with the most simple thing and then kind of expanded it until it was all done. So this is just for my reference. So yeah, so in can-JS now, in can-JS 2.3, in DoneJS, you're able to run your application in Node, and when you go to when you curl that or go in the browser, you're going to get the fully rendered page, which is kind of cool. So to make this work, we started off with, Justin actually did this part, is a project called can-ssr DOM. can-ssr DOM is a fork of a project called Simple DOM. And Simple DOM was made by the Ember.js team for their own server-side rendering implementation. We forked it to kind of add a few things that theirs didn't have that we needed. And the reason for that is ours, you can actually run jQuery on the server now using our DOM implementation, and you couldn't do that with theirs. But basically what it is it's just a very simple library that allows you to create DOM stuff. So it has a document. This is the implementation of document. It has document create element, for example. It has all the different node types, like text node and an element and a document fragment. So it just contains all the small pieces that you need for a DOM. However, it doesn't have all the advanced stuff. So how it differs, there's some full-featured Node or DOM implementations in Node, such as JS DOM, but those go to great lengths to try to conform to the spec entirely, and ours does not do that. It's just the basics that you need to render most stuff, basically. So that is what can-ssr DOM is. It allows you to create a document that you can run in Node, and that way when jQuery builds a DOM structure, it calls create element div. Well, that's going to exist now. That was the first part that we had to get working. Then I want to talk about can-util VDOM. So can-util VDOM just builds on top of can-ssr DOM, and it just adds a couple of things that are can-JS specific. There's not a lot to say about it, but I'll show you anyways. What is it? I'll go to minor branch. So in can-util VDOM sets up a world where you can use the simple DOM as though it's a document. It creates a new document from the simple DOM and sets it as the global. And it also sets it creates a couple polyfills for stuff that you don't actually need in Node, we're not actually going to be listening to events or anything like that, and location doesn't actually matter. I think we had to add that to make jQuery 2.0 just load. So this is what actually creates the global in Node. And there's a couple of minor things, we implemented inner HTML, so you can actually get all the inner HTML as a string, and that's what this does. It serializes it. You can set it as well, which is kind of cool. But that's all that can-util VDOM does. So once you have can-util VDOM, then you actually need a way to run this in Node. And that's where the system config comes in. And by the way, most of this you do not need to know, or you should not need to know to use server-side rendering. I'm going to get into how to actually use server-side rendering here in a minute, but I also want to go through how it works so that, you know, if you run into bugs, being that this is, still an alpha project, that you'll understand maybe a little bit better of what's possibly causing them. Okay, so the system config is just a configuration script that runs in Steel. Steel has a feature called config dependencies. If you're using npm, you can set config dependencies inside of your package.json file, and system config can be one of those. Now again, this is something that you should not have to do yourself, but I think you might have to currently, but it should be something that just automatically happens in Node. So what a config dependency does is it runs before anything else. It runs before the config actually. So when you load the page with Steel, it's going to run the config, which in this case is going to be the npm extension, and it's going to load all the dependencies before it actually runs the configuration's own code. And then it's your main is how that works. So the system config, any type of config dependencies are a way to set up, basically they're a way to set up extensions, or in this case we need to do some pre-configuration before we even start the application. So this is what the system config looks like. All it's actually doing is detecting if we're running inside of Node, which we can do that by checking for process will be kind of a different, it's to string will be different than anything you would see in the browser. And then it also sets some configuration. So this is just the same as running system.config yourself. You can export an object called system.config, and this object is configuration options. So the one that matters is jQuery. So what we're doing here is we're preventing jQuery from loading before VDOM loads, right? Because where I showed you before, can-util VDOM is what actually sets global.document, and it sets the window, and it sets the add event lister, and all that stuff that jQuery expects to exist. So yes, that's how we make sure that the VDOM actually runs in Node. So yeah, that's all system config really does. And otherwise, it's going to map can-util VDOM to empty, which just means load nothing. But actually, you should never be importing can-util VDOM yourself. You're always going to be loading it kind of implicitly as part of this special script. So that is system config. All right. So that's the base for just making it so that you can run jQuery code inside of Node, because that's the first thing you need, is you need to be able to run our apps. So we can actually run our apps now, but we also need a library which implements a little bit more and makes it easier for the user. So, which is where can-ssr comes in. So everything clear so far, guys? I'm assuming I'm not by myself right now.
Yep.
Okay.
So far, so good.
Okay, good. So what can-ssr does, it's a library that you would use. This is something a user would use to do server-side rendering themselves. So you install this as a Node dependency, and you just require can-ssr, and can-ssr is going to return a function, and you call that function with configuration options, which this is, if you've ever set up Steel build before, it looks exactly the same. Basically, you just give it your config, and actually we're giving it a main here, but you actually shouldn't have to give it a main because your main is going to be inside of your package.json. But any of that type of stuff that you can do with Steel tools is the same thing that you do here. We call this a system object. And what that's going to return is another function. So basically, at this point, can-ssr knows it knows how to load your application in Steel, and then it's going to return a function that you can call with just any route, and that will return a promise that will result in HTML. Does this make sense as a API? I hope so. I thought it was a pretty...
As an API, yeah, but it seems a little magic right now. Like,
you think so?
Well, yeah. So where is
definitely...
orders, or what is orders? Like, is that route already set up to like be something? Is there like a... I'm just a little confused about that.
Okay, cool. So yeah, that's one of the problems we wanted to solve. Is you already have to set up your routes when you're creating a can-ssr project, right? We didn't want to have to create those routes in Node as well. Do you know what I mean? Like we don't have a server file that just repeats a lot of stuff. You've already defining your routes in one place, so it already knows about the orders route because that was defined. Here, I'll use place my order as an example. So the place my order app is based off of this index.stash. It's just a stash file. It imports pmo/app, which is the app state, and it actually sets up the routes. Cool.
Yep.
So I'll go behind the scenes, and we'll actually look at can-ssr's code, because this is the one that I was most curious about, because it's the one that this is the one that does not necessarily magic. Like this is all stuff that's built into Steel and can-ssr and whatnot, but it's kind of hiding the complexity from the user a little bit.
Sure.
Is can-ssr what's actually running on the domain placemyorder.com, or is it or is there a web server calling the renderer?
No. Oh, so you're saying are there multiple servers set up? Yeah, we only have one server.
Well, is there is there something in front of it, or is it handling requests directly? I guess.
I think what you say is can-ssr the server.
No, can-ssr is just a node. It's actually both. It's a node module, so you can write your own server and use can-ssr, which is what we're doing here in the example. It also comes with a can-serve server, which is just kind of a bare bones server, which will do proxying for you and also do server-side rendering. So if you just need kind of a bare server, then can-serve is what you should use, and that actually comes as part of can-ssr. But otherwise, yeah, it doesn't actually. So let's go back to this. All it does is it returns HTML. It doesn't handle requests itself. You have to, if you were going to write the code yourself, you would start up Express or Happy or some other type of node server, and then just run this, with the URL. If that makes sense.
How does the server get the output of that? Like, you're not exporting anything in that little snippet. So how would the server get access to this module's, for instance, orders route output, and then serve that?
Right. So let's see if place my order actually does this. If not, I'll write some code myself. I can't remember if place my order is using can. It probably is. Okay. Well, I'll just write some code then. How about that? So. All right. Let me do a file. So, can-ssr you get from can-ssr, and this is a function that will return a render function. So we could say render is equal to can-ssr, and then give it a config option. Which all we need to do is provide the location to our config file, which is we're going to use the npm plugin. Then you would also do something like start an Express server. Trying to remember how Express works, but it's something like require Express, like that maybe, and then you say app.get actually, you might just be able to do app.get, and this will run for all GET requests. And you say app.listen 9000 or something like that. And then from here, it's going to pass you a request and a response object. And then you can say, I wish I had placed my order, because I don't remember exactly how this code is. Let's see if it's listed here. Oops, I'm looking at the wrong thing. Let's do place my order. Place my order API.
Yeah.
Is that it?
Yeah, place my order API. That's the same.
Let's see if that's. Actually, I might be able to look at can-ssr. Maybe can-ssr does it. That's actually probably where I should look. Yeah, so this is exactly it here. So basically, we're capturing all routes, and we're getting the path name. You can kind of parse to get the path name, so that's what's going to give you your orders. And then you're going to call the render function with that path name, which is going to return a promise, which gets the HTML. And then you just send. You call rest.send with the HTML.
Cool.
So you could use it with Happy, or there's other Node.js web servers, but yeah. So can-ssr is just kind of a very basic HTTP server that you might want to use. It actually probably would work for most use cases, but if you have extra stuff, you want to do it manually. But it's still like so little code that you actually have to write.
So can you covered it a little bit, but I'm still a little foggy on it. So that path name, so it calls render with the path name.
Yes.
Like, what is the renderer doing to your app to get that HTML?
Cool. Let's go over that. So this is the function that gets returned. What it does is it starts up your application, which actually we started up when you first call with your config options. So it should already be started up, already in most instances. So this promise is going to return right away. It returns an auto render function or an auto render object. So at this point, you have to use done auto render, which is another library. So right now, and I think we can probably make it so you don't have to do this. I don't remember the reason why we have it like this now, probably just to get it out the door. But done auto render is a library that allows you to use a stash template as your main. Basically, this becomes your entry point into the application. And on the client, because this is your main file, it's going to take the parts that are inside the head and it's going to put it into the head of the document. And it's going to take the stuff that's in the body and put that into the body of the document. So what you wind up with is your entire HTML is all live bound. So you can do any type. You can like change the title. You can do whatever you want to do, which is kind of cool. But what done auto render does is it exports a special type of object that can-ssr knows how to deal with. And what the main bit of it is, and this is the part that I think we can actually move out, is this render async function. And render async is what actually allows you to render a template asynchronously. And we need to do it in this case. Now I'll go over why that is. So let me go back to this code for a minute. can-ssr. Okay, so the object that it gets is an auto render object, which is created as part of this auto render plugin. So it's basically it's what your template compiles down to. Your template compiles down to an object with a couple of functions on it. Does that make sense?
Yep, with you so far.
Okay. So then it creates a new document because for each request we need to have our own document to like put stuff inside of. It creates a new state object, which is your view model. So with done auto render, you're gonna provide. Actually, it didn't show it. You don't have to do it with done auto render, but like place my order has it specifies an app state object, which is here. This is the special syntax which says that this entire template is equal to this value. So basically, what it means is that the view model for this template is PMO/app. So PMO/app is an app state object, which is just a map, a special type of map. And we'll go over what that.
So it imports the map or the app state, and then it saves it as
the view model.
So
Yes.
what is the value part of that expression for? Oh, it uses the value of the import to save it.
Uses the value of the import. Yes,
Gotcha.
exactly. So this exports a constructor function called appState, and we're going to use that as the view model. So for each instance, for each user, we're going to have to create a new instance of the map and put some state stuff into that, and then we're going to use that. Okay, so what it does is it calls state.adder, and it calls can-route-dparam. So what can-route-dparam does is it takes a path, which in our case we'll say it's orders, and it because it has all the routing information, it can take the URL and like create an object which represents that state, and so we set that as the state. And then we also set a special an array called rendering assets, and I'll get into what that does a little bit later. But that provides a way to where you can also server-side render kind of like CSS and stuff like that. But anyways, so autorender.render is the actual render function. Just like in any other can.js stash, when you call can.stash with a string, it returns a render function. That's what this is. So you pass that function into render async with your state object. I think this is the options in your document as well. And so can auto render is what's going to actually render it asynchronously, and it's going to return a promise that resolves with the actual HTML.
Neat. I have one kind of stupid question.
No,
Line 28 and 29.
Yep.
Auto render has a reference to render, but then you have to call autorender.render async. Auto renders renderer.
You're right, because originally this was not render async was not part of the auto render plugin, and actually now that I'm thinking about it, I don't see a reason why it should be tied to that. So it was going to be a separate thing that you could just pass it a render function, and it would do it. It kind of makes some assumptions about how it's going to be used.
Okay. Cool. I was just curious.
Kind of is sort of tied to it, but I think we can probably pull it out. That's what I'm saying. As far as for now, it's kind of it's all tied into a particular workflow where you use auto render and you use a stash file as your main. But I think we'll be able to break this apart so that we won't have those restrictions.
Sure.
So let me talk about what render async actually does, because that's kind of a cool part. So the problem, actually before I show this code and distract you, let's just talk about what the problem is that you have. So remember that whenever you call render, the render function for a can-stash template, it's just going to return you a fragment. But that fragment is not fully formed yet, right? Because inside of the user code, you might be loading, stuff from the server, or you might be dynamically importing another module. There's all kinds of async stuff that happens, and that fragment is not actually done yet, if that makes sense. And over time, that fragment is going to be filled up with all the additional stuff as stuff renders asynchronously. So that was the problem that we faced, is like how do we know when rendering is actually done? Because in the server setting, you want to return all of the HTML when it's actually all completely 100% finished. So this is what render async does. So what render async does behind the scenes is it creates a, or it might already be created. Yeah, there's an object on the state instance called ready promises, and these are just promises. Yeah, it's just an array of promises. So what render async does is wait for all of these ready promises to resolve, and when it resolves, it actually has to do this. What's the word? My mind's not working. What's a function that calls itself is called a, help me out.
Self-executing function?
No, I mean yes, but recursive. Gosh, sorry.
Yeah.
It has to recursively do this because all the promises might resolve, but those promises create a new promises, if that makes sense. So, like for example, you might dynamically import the orders page, but then once you've done that, the orders page has to make an AJAX request. So it's going to create a new promise. So we have to recursively wait until all promises are resolved until there are none left. And when there are none left, we can just kind of return. Yeah, so what it actually does is you pass in the document, and it's going to append the fragment to that document because we actually need the entire document's contents. Make sense? Okay.
Yep.
So yes, okay. So now it's a good time to talk about the app map. So the app map is just a can map that has all of this special behavior built into it. So if you make your app state an app map, it's going to have a couple of additional functions. One is wait for, and wait for is a function that you can call to wait on a promise. So inside of your own code, let's say that, let's get rid of this. Let's say that you have a view model, can.map.extend, and you're using define, and then you have like, I don't know, let's say orders is an object, and you have a getter to actually get them, and you like call like orders.findAll, right? So this is going to return a promise. Well, there's a special property in the view models called root. So you can say this.adder at root, and what root is the actual app state object. So this is your application's app state object. So it's going to be an app map most of the time. So if it's an app map, so it's clear, this is extending app map. So the instance of the app state is what you get in root. You can call wait for promise, and then you're going to return the promise here as well. So this is a way of telling server-side rendering that you need to wait for this promise to resolve. Because once a promise is resolved, then the template will be fully formed. So it has that, and then the app map also has something called page data. And the page data is another function that you can call with set data. And the reason for page data, and actually, if you in most instances, you'll only want to call page data, and page data will call wait for you. But what page data does, and I wish I could show you an example, but I don't think I have it set up correctly. Actually, I might be able to show you how to use it though, because can-connect will use this internally. Let's see if I can find it. Page data. Yes, okay. So if you use the can tag, I don't know if you guys have seen this, but there's a new can tag feature with can-connect that allows you to create a kind of a model component. And internally, so if you're using can-connect, you don't actually have to do this yourself, but if you're doing it in your own code, you might. So it's doing it here. It's getting the root, which this is going to be an app map, and it's going to call page data with kind of the name, which is It's kind of the name of this particular type of data, a set and a promise. And what that does is it actually adds, I'll show you what it's supposed to look. Well, I'll show you how it should look. My local place my order is not quite working right now. I didn't have time to fix it. But what it does is it creates this script tag with an option called inline cache. So this inline cache is all the data that was returned from all the different AJAX requests. So that when can-connect starts up, when it starts up in the browser, can-connect can check for this inline cache and knows it doesn't need to make another request. Does that make sense? It's kind of a way to prevent unnecessary requests and makes your page load quicker as well because it's not doing unnecessary work. So yeah, if my server-side render, if my local setup was fully working here, this would be an option. This would be a large option with all the different data from the server. I think I don't have my Mongo working correctly. So yeah, so that's what page data does, is that you're able to provide it a key and the set that you're interested in. Okay, so that's the app map. So it's a special type of map that knows about stuff that's needed for server-side rendering. All you have to do is use the app map in your own code, kind of like we did here. And you kind of get all this stuff for free. You might have to use wait for sometimes yourself, depending on whether you're using can-connect or not. But that's what that does. So, okay, what should I talk about next? Okay, I've talked about can-ssr. I've talked about wait for. Let's review because this is kind of one of the more interesting parts. Is kind of just how this all works. It calls auto-render, calls render async. Render async waits for all the promises to resolve. And then it triggers a special option called rendering complete. And this is where we get into like one of the more complex parts of it, but it's kind of fun as well. So with server-side rendering, let's see if I talked about this here. Yeah. So there's a special helper that you get with server-side rendering called asset. And what asset does is it knows about all the different type of assets that are kind of that live outside of the actual render function, if that makes sense. What I mean by that, okay, so CSS is a perfect example. When you're using CSS in your page, like you don't put a style tag in your template, right? You just import some CSS inside of a module. Let me show you place my order doing that. Place my order. It's been a long time since I've seen some of this, so the details are a little bit fuzzy. Maybe it's happening in the index.stash. Oh, yeah, so there's a separate place my order assets project that we created. And I believe that contains the actual CSS. Yeah, so its main is the less file. So by importing place my order assets, it's just gonna load all that CSS and stick it inside of the head, but that kind of happens in the background, if that makes sense. It doesn't happen explicitly, as Stash doesn't put the CSS in the page. It kind of happens, the CSS plugin actually does that.
How does the CSS plugin know that what was loaded in that project is CSS?
How does the CSS project know what was loaded?
So you loaded the assets project with steel there.
Okay.
And it set its main to, what was it, style.less or something?
Style/less, yeah.
Okay, so then that ran the less file like it usually does, but then how did the asset helper know to use the output of style.less, style.less as,
right,
quote unquote, the CSS? Sorry. That doesn't make sense.
That's a perfect question. So that's what I was going to get into now is what this asset helper does. So this asset helper knows to associate a certain type of asset, and it knows to it's gonna run a special function which will return a fragment that's going to insert here. So it's basically we have an API for this that any type of code can implement. So where is that? Yeah, so it's this asset register. So a module, this is not going to be in user code. This is going to be like some type of plugin or something. It's going to use asset register to, in this case, so we're registering a module called module/name, and the type is CSS. And this is a function that can be called to return an element or a fragment or whatever, any type of node. So in this case, it knows because there is another module which registers itself as a CSS. It registers different CSS modules, and it knows to call this function. This is what the asset helper actually does. So let's do a deep dive into this, because this is actually one of the more complex, but actually one of the more nice parts of server-side rendering is that it's able to actually do this. So let's take a step back. Actually, let's go to steeljs.com. If you've worked with Steel projects for a while, you've probably run into system.instantiated. So this is usually used for CSS. So what you do is you're going to put a link tag in your page inside of your HTML, and then you're going to mark this particular module as already being instantiated, and that tells Steel that it doesn't actually need to load that module. So this is usually how we do CSS in production. Is you just put the actual built CSS into a link tag, and then you mark it as already being instantiated. This is, well, there's two things. First, this is kind of low level. This is like not very user friendly, because most users are not going to understand what this actually is. But the other point is that if you have when you're doing progressive loading, and this is what we ran into, is you might have multiple CSS files. So for an order page, so we have usually you have like a main CSS, which is kind of all of your app level CSS stuff. But then on the order page itself, that's progressively loaded, it has its own CSS, which only pertains to that particular page. So there's not a good way to do that with instantiated, because in most projects you're only going to have a single production HTML file. So you're not going to put all the link tags for every single page, because that's wasteful. So there actually wasn't a good way to do this, and we kind of realized this when we were developing this feature. Is we realized that we've never actually done progressively loaded CSS correctly in the past. Basically, you always put your main link tag in the page, but anything else is not going to be. It's going to be progressively loaded, but you're going to get the flash of unstyled content problem, because it's not going to be loaded when the page initially loads. It's going to be loaded async. So this is the problem that we were running into. So that's that was kind of the impetus for the whole asset idea. The first go at this, what I did was okay. So remember, we load your application inside of a fake virtual DOM. Anything that your application does to that DOM, any modifications it does to it, are going to be there, right? So if you're using the CSS plugin, and the CSS plugin, so what the CSS plugin does is it creates a new style tag in development mode. It creates a new style tag and puts the CSS text inside of that and puts it inside of the head. That's what the CSS plugin does. So the first go at it, what I did was I just checked, like inside of the virtual DOM's head element, give me all the style tags, and I'm just going to return all of those. Does that make sense? So what that does is that just returns everything that has been loaded whenever, right? So when the server first starts, all that's going to be is just the main CSS. But the first time a user goes to like /orders, it's going to load the /orders CSS, and that's going to be part of the document as well. So what you wind up with is you wind up sending all the CSS that exists, so you're wastefully sending way too much stuff. So that's what the idea for this register helper is, that a module could, any module could register itself as kind of like a spokesman for this type of asset. So I created the DoneCSS project. So this is a lot of projects, right? And I'm sure it's
Absolutely.
but it's kind of nice because you don't have to, like I said, you don't actually have to know about most of this. This is when you're getting into actually wanting to modify it or something.
I liked the description on that one. A CSS plugin for CSS.
Yeah, I think this project needs to be updated. Actually got the wrong URL. Oh no. CSS. So the DoneCSS project is, it's even got the wrong name. I renamed it. The DoneCSS project it's almost exactly the same as the regular CSS plugin that comes with Steel, but it just has this one bit of extra functionality, that is, it knows about this asset register stuff. So you see at the top here, what it does is it checks if that a asset register module exists, and if it does, it gets it. So this is going to be a function. This is going to be this function here. So it's not requiring it explicitly, even though I guess it probably could, maybe. No, actually it couldn't, because it's not going to run. Asset register doesn't exist in the client. It only exists in Node. But anyways, what it does in dev is, so this is all the code that the CSS plugin already does to create style sheets. And then it's going to do an additional thing, which is call the register function with the load name. So this is going to be like, it's basically going to be calling something like home/home.less. CSS. Well, it's not going to be less. Well, yeah, actually, it could be less. It's going to return a function, and then it's going to clone the style, which is just a style element, right? So it's basically, it has this element in memory. It's just going to reclone it every time and give it back to can-ssr. So that's how the CSS works. So what's more interesting is how this actually works under the hood. I've only got about 15 minutes, so I'm going to go through this part. Actually, we're almost done, so we might have enough time to go through this pretty well. Okay, so what can-ssr does is it loads a Steel extension behind the scenes. So a Steel extension knows about, and Chris, you've worked with some extensions now that you're going to understand a lot of this, but what an extension does, it knows about the different hooks in the loading process, and it can override those hooks. And in this point, in this example, what we needed was a way to be able to register assets. Go back to this. I'm trying to think of how best to explain this. We needed a way that, like for example, the CSS module could register itself as the owner of this particular module. But the difficult part is that we only want to load this, we only want to clone this if the page the user is interested in has this CSS. Does that make sense? So let's give some examples here. My little scratch pad.
So you want, let me try and like kind of translate what I'm hearing. You want to register an already rendered CSS link tag.
Yes.
With or style tag to that loader, that module name. So when that module name is required, it's not going to go get a file and then parse it and then do all the blah, blah, blah. It's just going to go get that style tag.
Well, yeah, well, exactly. And remember, a CSS modules are only imported once ever.
Sure.
That makes like if you require home.less and then you import it later, well, you're just going to get it's already happened, right? So there's only, it's kind of like it's a one-time thing. So we needed a way to like be able to we needed a way to be able to keep the CSS in memory and give it back to can-ssr when it needed it.
Oh, so that each like route re-render doesn't go through that process all over again?
It wouldn't go through it. It couldn't go through that process all over again because it's only going to happen once on the server. The same way it only happens once on the client. So basically,
what is it doing additionally that the standard import doesn't? That's the part I guess I'm missing.
So the import is going to, the standard import, so when you do an import, remember there's a virtual DOM running inside of Node. Or running is not the right word, but there's a virtual DOM structure that exists. You're going to have a head. So when you do a can import, it's going to put a style tag here, right? But remember, this is inside of Node. This is like global dot document element dot or actually I think there's a document head, right? Document head and child nodes. You know what I mean? This is an object which exists inside of Node. So this exists inside of Node, but we need a way to be able to clone it, right? Because it's like it's that, right? So we need to be able to clone this because we want to stringify it and return it as part of the HTML. Let me do a quick curl. It might actually I've already done it. You see what we have here? This is actually not the prettiest thing to look at, but we have the actual style tag in all of the styles. This is dev mode, so it's okay. Sure. But we have all of this returning as part of the request. So what it does is, I'm going to explain some data structure stuff, so the user might be requesting like /home, right? Well, you only want home.css, right? You don't want orders.css, right? Mm-hmm. So there's going to be multiple style tags. There's going to be one for everything, right? Everything that exists in your project. But if we're requesting home, we only want this one. This is, we'll put an ID. Because actually it does go to ID. It creates IDs for this. This is home.css or something. And this is the one we want. We don't want all of them. So inside of the node global document header child nodes, there's all these different styles. We only want this one. So how do we know that this is the one that we want?
So let me get this right. The top one is our virtual DOM that's kind of like actually running our app, and then the bottom kind of route that you're mocking up or pretending that the user's enacting is actually going to extract a copy of the HTML to be served.
Yes, exactly.
Which will only include that style tag with asset ID home.css.
Yes.
So even though the virtual DOM has rendered a bunch of style tags and gotten everything that the whole app need, we only want to serve up
part of it.
A particular style tag. Gotcha.
Exactly.
Cool.
Okay, so to make this work, remember we have an API, and the DoneCSS plugin is going to register particular. It's going to register that we'll say it's CSS just for simplicity. It's going to register that home.css, but we still don't know when we want home.css. Like how do we know that? And the way is, so what we need something that's unique as part of the rendering process. So when you run a rendering function, all the code that all the other functions that get called, one of which is can import. So you say can import from, like, let's say PMO/home, and then you're going to have some stuff inside here, which is like home page or something. So when we actually render, when we do the server-side rendering, this can import code is going to get called, and we're going to know that this particular import is being imported as this particular route. Does that make sense? So what we do is we override. Let me see if I have my extension. We override can import, and we keep a list of everything that's being requested. So let me draw this out a little bit better. Okay, so the user says, give me /home, and it's going to run index.js, which is going to have some HTML, and it's going to have a body tag, and it's going to do something like can import from equals home. And internally, the home component, home.js, like, it imports component from can component, and it imports home.css, right? Now remember, this all happens kind of up front on the server. So what we have to do is, so when we run the rendering function, like remember, it's just kind of like getting a can.stash, and we're going to get index.stash. Actually, I think, well, whatever. We'll do it as a string. We're going to have all that stuff, right? So when you call render, it returns a fragment. That fragment is going to run this can import statement. So inside of our extension, which overrides can import, where is it? It has this special thing called rendering assets, right? So basically, it's saying is that we need all the assets for home because we're can importing home, and well, actually, there's probably only going to be one for each particular page. We really only care about home because you're usually going to have some other can imports down here. But in this case, this can import is not going to resolve because we're not requesting it. Oh yeah, so this is going to be inside of like, I'm sorry, I should have done this before, but this is going to be something like equal page home, right? And this is page orders.
So this is what associates it with the app state. And
Yes.
then, so now your routes that were done with the renderer are now linked to can imports.
Exactly. So we know that we need home. But however, we need to associate home with home.css. So this is the part that's unsolved. Is how do we know that home is what loaded home.css? And the way we do that is we override, what do we override actually? Yeah, we override normalize. So normalize is a function which creates module names. So what we do is we wind up creating a map of all parent modules. So you have home.css, it's a module. Let's say its parent is, let's say it's not home, let's say it's like, I don't know.
Checkout.
Okay, sure. Its parent is checkout, and checkout's parent is home. So what we do is we keep a map where what we can say is that when in user code, or excuse me, when the plugin says register home.css as a CSS, what it's going to do is it's going to walk up this parent map. So it's going to say, okay, you're asking for home.css. Home.css's parent is checkout. Checkout's parent is home. Home doesn't have a parent. Therefore, home is like the top level bundle. Cool.
Yeah.
So that's how we know that home.css is owned basically by home. So when we actually run this asset helper inside of your, inside of your stash file, it's going to say, so for all the different CSS types, so we have another map somewhere which says all these CSS types, here are all the modules associated with it. And we do that whenever you call register. Register is going to look for all the different, it's going to walk up the parent map, find the top level parent, and say, hey, home it's going to create like another map, which is something like home, and it's going to have a bunch of bundles. And one is going to be home.css, and it's going to have a type. Type is CSS. It's going to have like some type of value function, I believe, and the value function is just this function. So it's going to be something like return style.clone node true. So internally, what this helper does is, might have already had that open. What the asset helper does is it goes through each of these bundles. It sees if it's the correct type. So if the type is equal to CSS, and we haven't already inserted it, it's going to get the node value. It's going to set an attribute, which is an asset ID. That is, what's the particular asset. So it's also going to have an ID. Actually, the ID is the name right here. So it's going to create a bunch of, it's going to create a document fragment, and it's going to keep appending to it. But the result is going to be, this helper is going to have a bunch of style tags. Asset ID equals home with all the different styles. And then maybe there's like there's usually going to be like an asset ID equals, like main. Actually, it should be asset.css. So that's what's going to result from your asset helper call. Cool. And then the other thing that DoneCSS does is it's going to check to see if this particular ID is already in the page. And if it is, then it knows it doesn't actually have to load that. So this gets rid of the need to do the instantiated thing, because the DoneJS plugin is going to check through server-side rendering. Whew, that was a lot to go over. So that's probably didn't make a whole lot of sense. This probably could be broken down even further. But that's kind of the basics of what can-ssr does. The last thing I'll talk about is the side bundle, which is there any questions about that, by the way? Chris, are you talking?
Yeah, I said I'm good.
Oh, you're good. Okay, I did cut out there for a second. Okay, so side bundle was a feature that we needed to create production bundles. So a side bundle is a feature of Steel.js. So here's the problem that we faced. So remember, when you create a Steel build, it creates a bunch of files, a bunch of bundles, which are your progressively loaded stuff, more or less. So it contains all of your code, so it doesn't have to load all of your dev files. A problem that we ran into, remember that we had the system config file that I talked about before? The system config file checks to see, like, are we inside of Node? If we're inside of Node, we're going to set VDOM to be a dependency of jQuery so that it's loaded. Well, what happened when I first started doing the production builds is that the VDOM was being included inside of the build, which you actually don't want that, right? Because when you load the project in production, you don't want the virtual DOM stuff, in the browser. Actually, I believe it actually kind of worked a little bit. I don't remember why, but it actually kind of works almost. But you don't need it. It's kind of wasteful, and it's not it's not the real DOM, so it's not what you want. But anyways, what we needed was a way to, we wanted to create a production bundle that included just VDOM, because VDOM doesn't need to run all the time. So we've never had a scenario before where you want to create a bundle that only runs sometimes, if that makes sense. Like, that's never come up before. Because we always create production bundles meant to be run in the browser, and it's always the same. But here we're faced with a problem where we have two different environments. We have the browser environment, which has the document, and then we have the server environment, which doesn't, which needs this particular module. So what side bundle does is it creates another bundle that's not associated with kind of the main dependency graph, kind of a side bundle. That's why it's called that. So, oh, this is ugly folder name. Probably would fix that. But yeah, it creates a bundle here so that this particular bundle, this contains all of the VDOM code. Remember we have the can-ssr DOM, and this is the minified can-ssr DOM stuff, so that when you're running in Node, this code's going to execute, and it's going to load this VDOM bundle as, in the background, the production bundle, but it's not going to run that in the browser if the browser doesn't need it. So it's just a way to prevent, otherwise you would get all of this stuff would be kind of in your main.js file. And it would just kind of be, you wouldn't be using it, it'd be wasteful. So yeah, that's a side bundle feature. I can't really think, we were trying to make this somewhat generic, and when else would you use this? Well, you might use it if you have, the thought that we had is maybe you have some page that users very rarely go to, maybe the terms of service page or something like that, and it has its own code, but you don't want Steele to optimize that code because it might cause other pages to be bigger because of it. You know what I mean? It just it removes this particular module from ever being considered as part of the optimization algorithm. But yeah, this is one great use for that. So
that kind of makes sense if you've got
that's side bundle. Go ahead.
That actually kind of makes a lot of sense. I've worked on big projects where an entire site can be made up of lots of different teams. So
right.
I can kind of see that being you might want to start the dependency graph from different source kind of.
Well, it still does have a multi-app mode where you can have I think what you're talking about is you have a site, but it's made up of a bunch of smaller apps, and each of those apps. So we actually have a feature called multi-app build, which you can have multiple apps, and it will correctly optimize so that the user goes between these different apps. They're correctly optimized. But in this case, this is more about you have maybe you have some app or some page that's almost never used, and you don't really care you don't really care that that's optimized, and you don't want it to ruin the rest of the apps, the rest of the pages. So it's just kind of an unoptimized bundle.
So does it really just exclude it from the optimization algorithm? Is that all it does? Is it just keeps it separate altogether?
It keeps it separate, yeah. And anything that's not part of other bundles, there's some stuff that is shared still, and that stuff is going to be part of all the other bundle optimization. But anything that's only the VDOM stuff, because VDOM depends on can-util. Well, can-util is still part of the optimization stuff because it's used by the rest of your code. But all this can-ssr DOM is not. So it's just kind of created into a separate bundle. So that's really all that it is. And this is how you set it. You can set it inside of the meta options. You can set side bundle true if you ever need that feature. And I think you might have to do this currently. I think Alfredo was setting up a DoneJS site, and he had to do this. But really, ideally, this should be baked in. This should be part of the DoneJS, its own configuration, because it can configure itself. Okay. I guess that's really all I have to say. Yeah, I guess the big points were how we know when a page is finished, and then also how do we know about other types of stuff that's not part of Stash's own rendering, like CSS, that inline cache stuff. That's just stuff that's generated. So yeah. Thanks, everyone. Is there any get off the sharing? Oh, we have a few people left. Cool.
No, it was awesome, Matthew. Thanks for the walkthrough.
Yeah, I know it's probably kind of confusing because there's kind of, there's a lot to it, and maybe we'll do it again. If you're ever interested in how it works, we can talk about it again. I really wanted to refresh my own memory because it's been quite a while.
How many kind of people have started building side DoneJS apps? How many times has it been new projects have been started from scratch? Would you say?
I don't know. I have mixed opinions on that. In some ways, it's not quite ready, but if people want to start playing with it, I know that Alfredo is doing a project. I think some other people started to. Brian might know more about that than I do. I don't really know.
Right on. Maybe it's time for me to give it a go. I've got a lot on my plate already, though.
Yeah. No rush.
All right, man. Thanks a lot. Appreciate it.
Thanks a lot, everyone. I'll post the broadcast.